Alright, today we're going to look at nonlinear systems of equations. We're going to focus mainly on solving algebraically. We haven't talked about different types of equations and how they represent different things. So graphing is going to be a little bit more difficult. That's not a big deal. Anyway, there's two things to note about nonlinear systems. A nonlinear system of equations is a system in which one or more equation is not linear. So that's actually a correction to the note sheet you have. The other thing to take note of is there can be one solution, you can have multiple solutions, you can have no real solutions, meaning you might have some imaginary solutions, or you can have infinite solutions. Now, what that means is there's a difference between multiple and infinite solutions. If we were going to graph it, it is possible that the two equations will cross multiple times, but not infinitely many times. So, we're going to, in our note packet, in our note page, actually flip straight to the back and go to example 5. We're not going to do the graphing ones. The first 4 we're going to skip. So we're going to solve algebraically the system, and I think I'm going to have plenty of room here to solve it. Y equals x squared plus x minus 2, and y equals 1 minus x. Now, just like with substitution, not even like with substitution, if we have a equals 2 and b equals 2, it's safe to say that a equals b. We're going to use that idea to solve this system. In this case, both equations equal y, so we're going to set them equal to each other. We're going to go x squared plus x minus 2 is equal to 1 minus x. Now we're going to get all the terms to one side. So I'm going to subtract 1, and I'm going to add x at the same time. So I'm going to have x squared. X plus x makes 2x. Negative 2 minus 1 makes minus 3, and that's equal to 0. Now you can solve this for x any way you want. You can take and factor it. That's what I'm going to do. You can use the quadratic formula since this is a quadratic equation. Or you could graph it and find where it crosses the x-axis. You can also do a whole bunch of other things. But I'm going to factor it because I know what numbers multiply to make negative 3 that also add to make positive 2. And those numbers are a positive 3 and a negative 1. So I'm now going to set each of those factors to 0 and solve them on their own. So I'm going to go x plus 3 equals 0. If that's the case, x would have to be negative 3. I'm going to have x minus 1 equals 0. If that's the case, x equals positive 1. So we've found the x values. We're going to take both of those and plug them into one of our original equations to find y values. So I'm going to actually use that second equation. Go y equals 1 minus negative 3. Minusing a negative is the same as adding. So 1 plus 3 is 4, which means one of our solutions is going to be at the point -3. For our second solution, we're going to do the same process. We're going to go y equals 1 minus 1, which means y is going to equal 0. So our second solution is going to be at the point 1, 0. And we finished our first example of the day. So let's check out another one. This is example 6 in our note packet. We have y equals x squared plus 3x minus 5, and y equals 2x squared plus 5x minus 4. Now again, they're both y equals, so let's just set them equal to each other. We can go x squared plus 3x minus 5 equals 2x squared plus 5x minus 4. Now, I'm going to move everything to the side with the x squared that has a larger coefficient, and that's the 2x. So I'm going to subtract x squared on both sides. I'm going to also subtract 3x. And I'm going to add 5. 2x squared, in fact, on the left side, everything's going to zero out. 2x squared minus x squared gives us 1x squared. 5x minus 3x gives us plus 2x. And negative 4 plus 5 gives us a plus 1. Now, again, you can use whatever method of solving a quadratic that you want to. I'm going to factor this because I know I can factor this one easily. I'm going to put 2 x's, 1 in each set of parentheses. There's only one way to multiply to make 1. That's 1 times 1. And if we add them, we get 2. So we have the same factor here. So guess what? We only have to solve that one time. So we're going to go x plus 1 equals 0. In that case, x is going to be negative 1. So now we're going to take negative 1 and put it into one of the original equations. I'm going to go with the first one just because there's no number in front of x squared. So we're going to have y equals negative 1 squared plus 3 times negative 1 minus 5. Well, negative 1 squared is 1. 3 times negative 1 is going to give us minus 3 minus 5. If we combine everything, 1 minus 3 is negative 2, and negative 2 minus 5 is going to give us y equals negative 7. So our solution is going to be the point negative 1, negative 7. And we're done with example 6. Let's check out our next one. Example 7. We're going to have x squared plus y squared equals 52, and 3x plus 2y is equal to 0. Now in this case, I'm going to solve my second equation for either x or y. If I have one equation and I want to solve it for a variable, I'm not going to do that with any of them that have a power. So I'm going to actually solve that second equation for x. So I'm going to start by subtracting 2y. So 3x is equal to negative 2y, and then I'm going to divide by 3. So we're going to have x is equal to negative 2/3 times y. We can then plug that in to that first equation. We can write negative 2/3 y squared plus y squared is equal to 52. If we square negative 2/3, we're going to get 4/9 because negative 2 times negative 2 is 4. 3 times 3 is 9. Y squared plus y squared equals 52. Now, we're going to combine the 4/9 and the 1 with the y squareds. We can think about this as the middle second y squared is 9 over 9 y squared. If we add 4 and 9, we're going to get 13/9 y squared equals 52. And instead of dividing by 13/9, let's multiply each side by its reciprocal, 9 over 13. So we'll have y squared is equal to 52 times 9 divided by 13. That's going to give us 36. Now we can take the square root and figure out that y equals plus or minus 6. So we can then take that and put it into the second equation to solve for x. So we know 3x plus, we're going to take and do this separately for the positive and negative 6. 2 times, we'll do the positive 6 first. So 2 times 6, that's 12. We'll bring our 3x down. If we subtract 12, we're going to have 3x equals negative 12. We then need to divide by 3. So we're going to get that x equals negative 4 in this case. So one of our solutions is at the point 6, negative 4. I've run out of room, so I'm going to clear my page so we can work on what to do with the negative 6. So just as a reminder, we had the point 6, negative 4. Now we're going to take the negative 6 and put it in for y. So 3x plus 2 times negative 6 equals 0. If I go 2 times negative 6, I'm going to get negative 12. So 3x minus 12 equals 0. If we add 12, we'll have 3x equals 12. If we divide by 3, we're going to get x equals 4. So that means our other solution is going to be at the point negative 6. I made an error in my ordered pair before. Let's fix that. I need to switch my x and y. So it's going to be at negative 4, the first ordered pair, negative 4, 6, and the second ordered pair is going to be at 4, negative 6. Oh, it's a good thing we caught that before we got too far. Anyway, we finished example 7. Now let's look at example 8. So example 8, which I think will be the last example for this video, and we'll save the last 2 examples for our next one. We're going to have the system y squared equals 2x plus 13 and x squared plus y squared plus 6x minus 1 is equal to 0. I'm going to use substitution for this because I have a y squared in both of my equations. I'm just going to take 2x plus 13 and put it in for y squared. So we can write x squared plus 2x plus 13, which we should get in the habit of putting it in parentheses in case there's a coefficient there, plus 6x minus 1 equals 0. Now in this case, we can drop those parentheses and start combining like terms. So there's just the x squared. If we combine 2x and 6x, we're going to get 8x. And if we combine the 13 and the minus 1, we're going to get plus 12 equals 0. So now I'm going to factor this. You can choose to not. You can do quadratic formula. You can do whatever you want. going to put an x in both. I need to know what numbers multiply to make 12 but add to make 8. Well, 3 and 4 multiply to 12, but they add to 7. 2 and 6, though, I can go plus 2 and plus 6. They work. So let's do that. Set them both to 0. If x plus 2 was equal to 0, x would be negative 2. And if x plus 6 was equal to 0, x would be negative 6. So now what I'm going to do is I'm going to take those numbers, and I'm actually going to plug them into the first equation to solve for y. So y squared, we can say, is equal to 2 times negative 2 plus 13. We're going to also do this with negative 6. 2 times negative 2, that's negative 4 plus 13. That means y squared is 9, and if we take the square root of that, we're going to get y equals plus and minus 3, which means from that we got two answers. So we've got negative 2, 3. We also have negative 2, negative 3. But we're not done. We're going to now put negative 6 in for x. So y squared is going to equal 2 times negative 6 plus 13. Well, 2 times negative 6 is negative 12. If I add 13 to that, that means y squared is going to equal 1. If we take the square root, we're going to get y equals plus or minus 1. So we've got two more answers. So our answers now are also going to include negative 6, 1, and negative 6, negative 1. So in this system, we have 4 solutions.